Hello everyone. We are going to be doing a lesson on histograms. You should have your worksheet that you got in class, which looks different than the one that I have here. This lesson is just going to be a quick lesson on how to create histograms. So once you've watched this lesson, you should be able to complete your practice worksheet at home. And if anytime you get stuck, come back and look at this short video so that you can figure out how to solve any problems that you might be having. So first thing I want to do is I want to look at the different kinds of charts. You have used most of these charts, so you should be familiar with them. There's a line plot, a stem and leaf plot, frequency tables, which we'll be building one today, and a frequency table is a count of the information. So you would take tallies. I'm going to zoom in on it so you can see. So you would make tally marks for everything that you need. And then you would count those tally marks up, and that would be your frequency. So for instance, 0 to 199 happened 7 times. And this part of the table is what's going to be important when we create a histogram. And then we have circle graphs. You can use those to make histograms as well. And we have bar charts and histograms. Now look at both of them together and you can see that they are slightly different, so don't get them confused with one another. This one has gaps in between. Each bar represents an item, a number or a word, for instance a color, red, blue, green, pink, yellow. On a histogram, each bar represents a range of a number. This is 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. Okay, and notice how the bars are equal distant apart because these ranges are equally distanced apart. You can also write your ranges, and this is really hard to see, but this says 0 to 20. This one says 21 to 30, 31 to 40, but I want you to notice the bars. This one is really fat compared to this one that's a little bit thinner, and that's because this range is twice the width as this range. This is only a range of 10 and this is a range of 20. Normally, and I'm going to tell you that they're supposed to be equal. You can do it this way, but the way we're teaching it is we want all of our ranges to be equal, not unequal like this. So all your bars will be the same width on your graph, and so that means that they're all going to be touching because you have a range of data. So let's see what we can do about histograms. Let's make one after we find out some information about it. Histograms, they are about frequency. Remember how many times something happens. You're going to have to count how many times something is occurring, and that's going to be your frequency, and we will use frequency tables sometimes to help us with that count. Bars are ranges or intervals. That's what I was talking about here. These bars represent a number or a word. These represent ranges of numbers or intervals of numbers. The bars are always going to be touching on a histogram, and the range or intervals must be equal. And when they're equal, you will have bars that will be the same width. If they're unequal, your bar will be a little bit wider, and we don't want that. So let's look at two examples of our ranges so we can see the difference. My range is from 1 to 3 here, which is a difference of 2. This one is 6, 2, and 2. So these three are the same range, and this one is a little bit different. Notice how it is larger. So if you were to graph this, this bar would be wider than these three, and these three would be the same width. We don't want that. We want them to all be equal. So when you're setting up your ranges, that's probably the hardest part, is making sure your ranges are equal. The other problem with this one is notice it ends at 13 and then it goes to 15. So there is a gap here. If there is a gap of 12, then that means these bars would not touch. So let's look at our second example. This one has a gap of 2, a range of 2. this one, oh, you know, this one should say, well, this one is messed up. So we're not going to worry about it because I forgot to make the change on this one. It actually should have said 4 to 6, and there should be a 7 to 9, 10 to 12, and so on. So when you have those ranges, now we have a gap of 2, a gap of 2, a gap of 2, or a range of 2. So now they're all equal. This is what you need to do. Sorry about the mistake, but those are the kind of ranges that you need. All equal. Let's try an example, and that will help you understand it better. We have 27th graders that were asked how many siblings mean brother or sisters, that they have, and the data is shown below here. Those are the results, and we're going to make a histogram from that data. Now, you're not always going to see it in a list of numbers, so I want you to realize we'll do this histogram from this list of numbers, but you can also be using a line plot in the same way we are going to do our example. You could be doing the line plot and graphing a 1, 1, 1, a 2, and you're going to find out your ranges and count how many numbers are from 1 to 2, for instance. How many numbers are from 3 to 4. How many numbers are from 5 to 6 and 6 to 7. That's how you would do your ranges, as long as they're equal. On a stem and leaf plot, it's the same idea. You have to look and see, so your range would be from 0 to 9, 10 to 19, 20 to 29. Now notice there is no 29 here, but you want to make your ranges equal. So you are going to still make it a 29 even though you don't have one listed in your data.